Welcome everybody to this session on industrial strength DALLE-E, scaling complex large text and image models. So we have a lot of really interesting content to go through. And as a reminder, the slides will be found in this link in the corner. You will be able to also find all of the resources of this talk. Now, one of the interesting things is that this topic is advancing extremely fast. So as you may all know, particularly people that have been keeping an eye on the text-to-image models, now you would know that there are kind of like things coming up pretty much every day, right? So whether it is DALL-E or Stable Diffusion, or the latest, generative large language model, large model, or any large model, as we're going to cover in this session, we want to make sure that the concepts that we're going to be delving into apply beyond just these examples. So to give you a little bit more of an overview, today what we want to talk about is large X models, right? So it's not just language or text to image, but just basically models that perhaps require complex considerations in order to deploy them. We will delve into some of the challenges that often have to be faced when moving into productionizing these models. We're going to dive into some of the solutions that can be used for this. And then we're going to be delving into a very interesting example, actually leveraging two large models, in this case, both GPT-2 and DALL-E, following by some closing thoughts. The resources for today, you will be able to find them in this repository. So this is basically on the GitHub, slash DALL-E runtime, which you will be able to play around. Just as a brief about myself, as per the introduction, my name is Alejandro. I am Engineering Director at Seldon Technologies, Chief Scientist at the Institute for Ethical AI, and Governing Member Council at Large at the ACM. Ultimately, a lot of the tools that you're going to be seeing today will leverage some of the open source stack from our different organizations. So first, let's dive into the why, right? So why are we talking about large X models? And the reason is because we're currently finding that even though there are some quirky and mind-blowing examples that we're seeing in the coming up in the internet, there has been also really interesting applications that have become practical from these large models. So developing immersive AI-based application is now becoming a reality. Tools that can allow for interactive, consumption of these models are now possible. So as practitioners, we now want to ask the question of how do we get value from these large models? How can we start actually productionizing them and using them in our day-to-day applications? Now, before diving into that, we need to understand, well, what are these large X models? So this type of models are starting to be referred to as foundation models. So tend to be, models that are really trained with a very vast, broad, and large data set with also large compute, resulting in models that would, as the name imply, be a foundation that organizations can use to build upon, right? So this could be building upon for, transfer learning, or actually using, zero-shot learning or end-shot learning for particular use cases. Now, these models can have either vertical or horizontal capabilities, and they can be trained with like very large data sets. So this is actually a really interesting visualization of the data sets that have been used for large X models, in this case, text-based models, and the relative size between, so the GitHub model, et cetera, et cetera. So the large, X models, the LXMs, have different use cases. So this could be for generating images, image captioning, parsing data, Q&A, et cetera, et cetera. And there's a broad range of fast-growing use cases for which they're using. And another interesting thing before kind of like delving into the use case is how there has been a shift into how academia and industry interplay with the creation of large of these LXMs. So currently we have seen that industry has been growing significantly in producing some of these models, particularly because large tech companies are funding the creation of these models internally. Now, it is important to mention that there is a large set of organizations that are producing these models, but it is not just a consideration of producing the models, but the creation of these models have also created a large number of questions that arise in the context of responsible AI, AI ethics, and basically best practices to ensure that whenever not only these models are being trained, but also they are, more importantly, being used at scale, the considerations are taken into account proportionate to the risk that is involved, right? So if you're actually taking a large language model or a large image model or text-to-image model, and you're actually building an application for users to consume, there has to be best practices that not only have to be used, that have to be applied at the system level, at the practitioner level, but also at the use case level, right? And that is, of course, out of scope of this talk. But if you're interested, there is a recent talk that I gave at last year's PyData Global on practical responsible AI, which you can actually check out on the channel. Today, what we're going to be delving into is on the productionization challenges. And if we take a step back and ask the question of, well, why would we have to consider some of the challenges when dealing with LXMs or foundation models? The reason why is because this type of machine learning models open different challenges. They actually deal with specialized hardware, whether it is GPUs, TPUs, but also large number of CPUs or large amount of memory. There are considerations when you're productionizing this, right? Because if you have perhaps multiple models, you may want to ensure that you can abstract the hardware where it runs. And if you have perhaps multiple use cases, you may not want to have a single repeated version of a particular model for every single use case, right? Because it's expensive to actually have a running model. You may want to actually have the multiple use cases leveraging the same resource. There are, as we will see in this example, potentially complex dependency graphs, right? A model may not be just independent. You may not just be productionizing a machine learning model. You may be productionizing a machine learning system, right? And when you have that consideration, you have dependencies that have to be taken into consideration given how potential errors may affect things downstream and upstream. There is a challenge on reproducibility of environment, of code, of data, of models that also have to be taken into consideration. And there are, of course, the use case specific compliance requirements, risk requirements that have to be taken into account. Now, of course, these challenges themselves make it quite hard if we take every single specific use case, one by one, and we have kind of the machine learning engineering teams building custom code for every single one of them. But that's why we can leverage some of the tooling existing out there that will help us actually navigate through this process of productionization of ML. And we're going to be trying to get some sort of ideas about this with a practical example today. So we're going to be using the DALLE-E mini model so that we can run it in our computers. And I think now it's called Crayon. And we're not only going to be deploying a DALLE-E model, we're going to also be deploying a GPT-2 model. And to make things interesting, we're going to be sending an input to the GPT-2 model, which is then going to actually go into the DALLE-E model. So as you can imagine, the input will then generate some random text, or not random, but some output from GPT-2, which basically generates human-like language. And whatever GPT-2 generates, we're going to send it to DALLE-E. So we probably are going to get some weird surprises as we do this. So the first step of the productionization challenges, we're going to look at these two: reproducibility of components and compliance requirements, making sure that you can version all of the different areas of your models as you're productionizing them. So we're going to be using an open source project called MLServer. So MLServer is a FastAPI-based runtime for machine learning models. And these machine learning models can leverage existing or custom runtimes. Right now, there are existing runtimes for MLflow, HuggingFace, scikit-learn, XGBoost, etc., etc. And the reason why we're using this existing server, as opposed to just building something ourselves with Flask or FastAPI, is because this is using several best practices that have been already battle tested in production. So it comes out of the box with things like multimodal serving, with a standardized endpoint, with a standardized schema, metadata discoverability, as well as endpoints for REST, gRPC, and Kafka out of the box, as well as security by design. And of course, we're not going to be able to dive into all of these different things, but if you're interested, there are references at the end of this talk to dive into each of the different areas in more detail. Now, how do we interact with MLServer, right? How do we actually deploy a model with MLServer? Well, so it's actually pretty simple. If we're leveraging some of the existing runtimes, in this case, the HuggingFace runtimes, we can actually leverage the out-of-the-box parameters for the runtime itself. Because HuggingFace itself has access to the HuggingFace hub, we are able to just provide a reference to the particular model we are interested on running, right? So we basically don't have to do anything other than provide the configuration of the HuggingFace hub. And in this case, we basically just have to provide the name of the MLServer model that we want to load, the actual runtime. So in this case, we're using the HuggingFace runtime, which is part of the MLServer server. The number of workers. If we are using a GPU, we can use adaptive batching or micro batching, but in this case, we're not going to be using any of those extra configurations. And we can just pass now the HuggingFace specific parameters. So in the HuggingFace hub, we can basically say, I want this to be a text generation model. I want to use the pre-trained model in the hub called DistillGPT2, and whether we want to optimize it or not. So this is basically a HuggingFace specific component to use optimizations. This is all we need because we can leverage all of the underlying components. If you want to specify a particular HuggingFace model, you actually can, and that would just be custom parameters. So once we actually have this config file, the only thing that we have to do is we just have to run MLServer start. That will basically read that config file and run the configuration, so that we will have an endpoint that will be available. And we can actually send, in this case, that parameter. So in this case, because it's the GPT-2 model, we can send an input being something like, Selden is very curious about the matter. And when we actually send the request, we will be able to get the response of the model, right? So basically, what is the generated model? Now, let's go to the second part. Instead of actually using a prepackaged runtime, an existing runtime, for the DALLE-E model, we're going to create our own Python class. And this is how you create your custom runtime. And in this case, the only thing that you have to do for a custom runtime is a Python class with a predict function, right? This predict function has all of the logic that you want to run, as well as the logic to run any particular artifacts, right? So our custom runtime will first, when it initializes, we will load the particular model. And whenever it sends a request, it will run this predict function. The thing that it will do is it will actually first parse whatever input text it is into the model, and then receive the outputs, which is the image, and then return that image, right? So it's of course very simplified here, but it really is as simple as it looks. You're only needing to provide a custom Python class with any initialization logic in your init and any logic in your predict function. We will dive a little bit into that. For this, we actually are able to just run MLServer start with our Python file. The input can be that, something like a rainy day in London. And when we send a request to a model, we actually get the output, which is basically here in, the actual values of the pixels. The input being a rainy day in London, this is what it generates. So being quite interesting, quite simple. Now that we actually have the first part, we have a fully reproducible, model, an ability to serve it, an ability to version it, and we can actually load both models in the same server. Now we actually want to productionize it. How do we deal with the orchestration, the complex graph dependencies? For this, we're going to be using a framework called Seldon Core. So this actually uses MLServer internally, but it orchestrates all of the configuration for the large-scale deployment in Kubernetes clusters, right? So we're not going to be able to delve into a lot of detail. A lot of this is just going to be very high level. But the thing to remember is that whatever we did with MLServer, whatever we run locally, now Seldon Core is going to allow us to run it in Kubernetes production and handle basically that inference graph where we would be able to actually run the input into our GPT-2 model, which then would go into the actual DALL-E model and then provide us with the response, right? The simple way to do that is the same way that you would deal with Kubernetes, which is just with a configuration file or a configuration manifest. The parameters here are very similar. So we would provide a graph where the first step is that transformer. It would use the HuggingFace server, the one that we used in MLServer. It would then provide those parameters that we gave initially, so the text generation with distilled GPT-2. And then the next step of the inference pipeline would be our DALL-E model, which is using that container that we created with our Python class. So this will actually create a endpoint that will be able to actually send a request and then receive the response. Of course, again, this is probably out of the scope of this talk, but you will be able to actually check some of these things in the repo. And we have, I have other talks in the slides where you will be able to actually see all of this in practice in more detail with basically, overviews of how to perform optimization, or if you're more kind of like interested in the DevOps, how to actually delve into the Kubernetes side. But, given that this is a data science talk, we're going to be delving more into the Python side. Now, as a data scientist, what this will allow you to do is to perform basically what we can refer to as segregation of roles. A data scientist can be focused on training models, something like DALL-E, and basically the machine learning engineer can be focusing on productionizing those models into the production environments like Kubernetes. So this is just about segregation of responsibilities, making sure that data scientists can actually focus on the data science side, test in their local machines, make sure that everything works so that when it's in the production environment, it all just works out exactly the same, but with production grade architecture. Now with that, we can actually delve into a demo. So let's have a look. We're going to be using the repo that we showed. So this is basically where you can find all of the DALL-E runtime components. And basically I have the repo over here. So it's basically cloned. What we're going to be able to do is we're going to just follow the instructions that are provided, right? So it basically says that in order for us to run the example, we have to follow the instructions in the docs/examples README file. So this is basically a Jupyter notebook, which we will be able to use. And for us to use the Jupyter notebook, we have to just set up our environment. So this runtime provides you with everything to actually get set up for MLServer. This is actually created with one of the MLServer cookie cutters. So MLServer itself, when it's installed, it comes with a MLServer project init command that basically allows you to create like a baseline template. This was then expanded to be able to leverage that sort of DALL-E runtime. It comes with all of the steps to create the environment. So we would basically first create our Conda environment. We would then use the install for poetry. And then we would be able to download the DALL-E mini models and then basically run the start. So if we actually look at the commands themselves, they're actually quite simple. So, the Conda create basically just creates it with the existing environment. This basically installs all of the GPU related stuff. In this case, the CUDA toolkit, the cuDNN. Then when we actually install, we would use poetry. So poetry ensures that our environment is fully reproducible. And whatever I'm running, you will have the exact same in your environment. And then we will be able to actually run the local start command, which basically just runs MLServer start with that example. So let's actually now have a look at the example itself. There's also, some security components for being, production ready, but again, this is out of the scope of this talk. For now, let's actually look at that example that is in the docs folder. So if we look at the example, it also says that the first command that we want to run is the MLServer start. So if we run MLServer start docs example / multimodal, if we have a look before at what is in there. So if we look at the multimodal folder, we can see that there is a DALLE-E model folder and a GPT-2 folder. Inside, there are those settings that we talked about. So the one for GPT-2 is basically just saying, hey, use the HuggingFace runtime and use basically the parameters to load the distilled GPT-2. And then the DALLE-E model, it basically just says, hey, I want you to just run this runtime, the DALLE-E runtime class. So you may ask yourself, like, well, where does this come from? So this is basically what we are actually creating as our custom runtime. Whilst we're using an existing one here, this is one that we created as part of our project. And if you actually have a look, this is basically the Python class that we are referencing here, right? So this is our class DALLE-E runtime. So this is the one that actually has the init. It loads basically the model. And then in the predict function, that's when it actually calls that DALLE-E function. And you can have a look at that in more detail. So let's actually first run that command. So MLServer start. That will actually basically run MLServer to be loading basically all of those models. We can now see that it's now sort of running on that port. It now is starting to load those models. First, it loads the DALLE-E model successfully. As we were discussing, the interesting thing about this is that we can leverage the multimodal serving capabilities. So this same server has also loaded the GPT-2 model successfully, right? So within the same endpoint locally, now I have loaded both models. What this allows us to do is we can now actually interact with the server, right? So it basically says that it loaded GPT-2 and DALLE-E. That means that if we actually send a request to the /models/GPT-2, we can actually consume whatever is at that GPT-2 endpoint. And in this case, if we actually send the input cookies, we can see that the response is our generated output. So here it basically just says cookies.com. We actually want something else, right? Because we don't want to try to run DALLE-E with cookies.com. So, okay, so here it says cookies can be purchased in a box at the local grocery store, blah, 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 blah. So I think this looks like a nice input for our DALLE-E model, right? So now let's actually send this input, right? So this result string into our DALLE-E model. So now we can actually send a request again to the same running server, but now to the DALLE-E model endpoint, right? So if we send that request, because we're running it locally, we can actually see what's happening. So we can see that this input is now being sort of tokenized. We can see that the tokens are now available here. So basically this would be, cookies can be purchased. Of course, in order for the machine learning model to perform inference, DALLE-E has to first, convert this text inputs into machine readable tokens. We can see that it's actually now performing the sampling of the image tokens, right? And now basically what this means is that it's actually generating our basically, output DALLE-E model. Now, what we're going to be doing is once this actually finishes, which basically it now has, this is the image generated. It's now detokenizing the image, and then it's going to actually send the response that we're going to be able to receive here, right? So now it's basically finished. We have the result over here, right? So this is basically this parameter. We can now actually process the response, right? So this actually has a bunch of utilities that allows us to do that quite easily. And we can convert the response into a NumPy array. This NumPy array allows us to display the input. And now we can actually see in the input is some sort of hand over here with basically cookies generated from that text. So this is actually something that we have been able to test locally. We can now actually just test and play around with the DALL-E endpoint, right? So again, if we actually run, rainy day in London, we can see here basically our tokens, right? So we can see a rainy day in London. Here we can also see a rainy day in London with basically the initial and ending tokens, I would assume. And this basically just allows you to actually play with the DALL-E Mini locally as you see fit. Yeah, I think for now, one of the things that we were able to do is we can also pass some parameters. In this case, the parameter is the seed. We're just passing the seed so that we have a consistent output, so that the images that we generate are always consistently. And we can see that this is basically what it generates from a rainy day in London. So if you're interested, you can play with this. You can play around and have some fun with the DALL-E Mini pipeline, and you can then look to productionize it and deploy it into your production cluster, as you also have not just the commands to run it locally, but also the Docker files. Just as a reminder, again, the resources for the talk can be found in the repo, DALL-E runtime. The slides can be found over here, so you can actually access all of that. And we have a bunch of further resources that you can check out. So, resources for CI/CD for production at scale, production monitoring patterns, accelerating ML inference at scale, machine learning security, et cetera, et cetera. So please do check it out. So today we were able to cover an overview of LXMs or foundation models, some challenges in production, as well as solutions, and then this hands-on example with DALL-E and GPT-2, which produce some really interesting examples. So with that, I'll pause there, and if we do still have some time, I'll pass it over for questions. So thank you very much, and I hope you enjoyed this session.
Thank you, Alejandro. I think we have one quick question, which is just, could you share again the GitHub link for the talk?
Yeah, absolutely. And just a reminder that this link should also give you access to the slides, so that you'll be able to find all of the links through that. So in the meantime, I will also share the GitHub link as well.